So I said at the beginning of this that this was a panel that was really more about storytelling than just about technology. And I don't know if everybody else got that, but I was listening to some of these presentations and going back to our, Ryan, little exchange about books versus technology, and started thinking that a lot of these simulations, games, whatever you want to call them, and for that matter, working with data is kind of like the book equivalent of a choose your own adventure. That this really is a way of letting students drive the story, create their own story, whether that's in graph form or video form. And I think it's really amazing to look at the research that you two were presenting about the outcomes and how much this really does engage students. And so I wonder, in terms of getting this in the classroom, were you doing this during normal classroom time, or is this something that you had to do after school? Is this a voluntary activity, or is this part of everyday required classroom time to do these kinds of simulations?
So in this case, the 2011 and 2012 workshops were a summer program, so it was semi-voluntary. The students had voluntarily come to the Media Arts Studio at Cambridge Ringe and Latin. They did not know that they were going to be participating heavily in a climate change science project. And I think it's really important. One of the reasons why it's important that these students got to write their own narrative or write their own understanding with real facts, supported evidence-based understanding, is because that group of people went on to be chefs and are studying finance, or studying filmmaking, or studying medicine. That particular group, and we've done it with others, went on to all the different walks of life that we would expect them to be. We were not trying to convert them into either media nor scientists. And that's key, because in all those positions, they're going to need to make informed decisions that will change outcomes. And I remember one thing that Dr. Rooney Varga used to say to my students, because we always feared they're getting depressed with this news. And I think having a systems thinking view with points of leverage change that, and getting them to realize that the data points in the future are not written, and that they would be a part of what was to come.
Lynn, the data analysis that you presented, I'm assuming was part of classroom time?
Yeah. So the examples that I showed were from a classroom, as I mentioned, that's working. So the teacher in that classroom has been working intensively for about 2 years with one of my colleagues at NASA. And so this was her first attempt. So it's a teacher professional development program that she was learning, and then this was her first attempt at taking it into the classroom. And so she used it in her ecology class. As I said, the first attempt was basically she just let them loose. And so all of the students kind of picked their own, and as you said, wrote their own story. I think next year, from the learning that she's gotten, she's going to do it a little bit more structured. But it does offer that possibility to open it up, and the tool is there. You don't have to use it in the classroom. And so even if they introduce it in the classroom, if a student gets interested in something, they can go off and do whatever interests them.
Jason, in terms of the games that you presented, how do you see those, how much a part of formal education as opposed to, you mentioned this is entertainment, but there are a lot of games out there for people to choose from. Why would they voluntarily choose a climate simulation game over juice cubes or whatever else that pops up? Yeah, Candy Crush, whatever else is out there for them.
Yeah, I think, on the classroom side, being a former full-time public school teacher, still teach part-time in a classroom, it is about achieving that balance between assessment pressures, classroom management, the full gamut of things that you have on your plate, and balancing that with a desire to have the class be engaging and fun, inquiry-based. And so I think as far as the school side, there is that balance that is necessary. As far as the non-school side and the commercial side, definitely we need to develop games that are good, that people will want to play in and of themselves, not just because it's an educational game.
I want to get all of your thoughts on one of the potential strengths that games present that no real world situation can really provide. And that's, as you mentioned, low risk failure. We know that climate education is not just about knowing the facts, it's about gaining a toolkit, and part of that is risk taking and resilience. And it might be hard when your test score is at risk, or in the real world when climate is really at risk. But maybe in a game, it's okay to fail, and that could give students a skill they couldn't get any other way. Do you see that coming out of the experiences that you've been a part of?
Yeah, absolutely. I think that it's also this idea of being able to play with the system from a completely different perspective than you're used to, and that is probably going to lead to failure until you have an opportunity to learn from that failure and iterate. So, for example, we have students who are working with in Argentina and also in Nepal, and they often sort of come to it thinking, well, the developing world hasn't caused this problem, and we're not going to solve it. And so they think they don't matter, but they come out of the simulation realizing that it's all in, and actually they hold key leverage. But you don't want to have that failure happen in reality, right? It's a good failure to have happen in a really low risk situation, and then you can learn and move on.
Lynn, you presented a case where the data analysis went wrong.
Right.
Did the student learn from that, do you feel?
So I don't actually know the answer to that because this is kind of third-hand information, but in thinking about it, my thought is, what is more important? And this is maybe a discussion that teachers have, but is it more important that she got the right answer in that particular case, which really in that situation had nothing to do with her life or anything? Or is it more important for her to have experienced the process, as I said, the process of science, and taking the numbers and realizing that they meant something, and realizing that they were tied to a place, and realizing that all of these things, even if she got it wrong in the end, she still learned a lot in that lesson. And so I think, to me, again, it's a low stakes failure. It's you got the chance to learn, and in terms of thinking about assessment, what do we want to assess? What is the most important thing? Is the most important thing that she, mixed up the longitude, or is the most important thing that she did this process and did the graphs and all the other steps that went into that? And that's a discussion, I guess, for the education folks. But to me, there's a lot involved there beyond just the final piece.
But there is assessment in there because you realize that that's a piece that she needs. In
Yeah.
that helps the teacher learn
Right.
what the student is getting and isn't getting.
Right.
And one of the things I think with world climate and a lot of these tools is that some of the traditionally strong students in science classrooms may not necessarily feel strong or feel comfortable in this negotiating realm. It's a different realm. I'm not saying they don't, but what we found in the times that we've done it with our students and then times I've seen other classrooms is there's a role for everyone. And that's a great classroom experience. And we're actually going to bring it into the classroom experience at Ringe, working with some of the biology teachers to do a larger scale world climate, because it does give lots of different students a way of engaging in different ways to the material.
Jason, you're the one who actually mentioned low stakes failure. How do you think about building failure and not only the rewards you mentioned into games, but also building failure into games?
Building failure into games. Well, I will first say that I completely agree with your first point about the importance of having a comfortable environment where students are able to fail and able to participate without that pressure. As far as building it in, I think it's really about building in the right kind of failure and feedback. One of the things that we were looking at in some of our research on games was basically what kinds of feedback are these educational games and these different apps, what kind of feedback are they providing? Sometimes it's just a little noise or a ding. Sometimes it's explanatory. In general, it doesn't really go that in depth. Most of the educational games, they don't really give that much explanatory feedback. It's just very behavioral. It's you're right, you're wrong, and that's it. And so what we found there was that really behavioral approach that's really based on facts, really just black and white, right and wrong. There is something a little bit missing there as far as a more holistic and constructive approach.
I want to make sure we get any questions from the audience here. Can we get a microphone down here for Jenny?
Lynn, I was really happy to see your slide about the science fair and how it really doesn't represent science. And I'd love to hear from you and others on the panel, how might you reimagine the science fair so that it is more representative and relevant? And then how would you get buy-in from parents and teachers that maybe that's a new direction to go into?
Yeah, so that's an excellent question. I think it's a systemic problem that will have to be addressed somehow in the magic of the science fair. I mean, my understanding is that there are science fairs where they don't allow students to use data that they did not themselves take. And how does that represent reality? It just doesn't. I will say, small plug here, that NASA, we've just started a award within the Intel Science Fair for NASA Earth System Science. So in the next cycle, that's going to be one of the awards that's given. And what we're trying to do is start engaging with them and then start figuring out how we can work with those students that do those projects and start something. But there's a fundamental problem when you have school policy or district policy or fair policy that says you can't use other people's data.
I would also say class-wide competitive science fairs. You have classes competing against each other, requires everyone to participate, team effort. Although logistically it'd probably be pretty difficult, but definitely motivating.
All right, one last question here.
I'm curious about translation of people's experiences from the kinds of games that you've talked about to other kinds of situations. Someone mentioned the term systems thinking, and I'm wondering, for you in your work, do you think about sort of proto-thinking skills that are really deeply embedded, that go beyond climate change or anything, but that are 21st century skills that you feel are important to pursue?
Anybody want to take a stab?
We've thought about that a lot, so I'm happy to take a stab. So I think we're still in the early days of thinking about that in some ways, like in terms of the research that we want to do to test transferability, because like you say, systems thinking skills can be applied to any complex problem, and pretty much every problem, every major grand challenge facing society today is a systems problem. So that's a question that, when we look at climate change, there's so many fundamental systems concepts that could be transferred across. And I think it really depends on how they're presented. So for example, the fact that atmospheric carbon dioxide is a stock that accumulates as a result of emissions, right? We know there's a large body of evidence saying that people don't predict that behavior well. Similarly, time delays. We don't do a good job with time delays or nonlinear behavior, mentally simulating those behaviors. So I think there's a great opportunity. My first assessment is that the information has to be presented in a way that's also transferable. And then I would just say stay tuned, and we hope we're going to learn more soon.